Now, application layer protocols which we discussed, there are some three different layers. In the OSI, we call them as application layer in general in case of TCP/IP, which is going to create a session, defines the format, and then maintain the sessions. And there are some different protocols which we use in general, and each and every protocol have a specific dedicated job assigned for that. Now let's try to understand or discuss about these different kinds of protocols we have and what exactly they do and how they work exactly. Now everyone know about this HTTP. We generally access web pages. So whenever you type any URL path, it's going to open up a web page, and that web page will be opened by using some browsing software, some web browser softwares. But the backend protocol, there is something called HTTP, which will allow you to access these web pages, hypertext transfer protocol. Okay, now even you can have something called HTTPS. Now the only difference between this HTTP HTTPS is, now normal HTTP will have all the information will be in a clear text, which means anyone can read that information if he captures your traffic. Now probably in case of HTTPS, it will be more in an encrypted text. Most likely your banking sites or any online payment kind of things, they generally secure your sites by encrypting all the information so that it should not be read by anyone. But at the end, HTTP is going to allow you to access web pages. So there is a backend protocol called HTTP, and it works on port number 80. Now similar way, we have some other protocol like FTP protocol. FTP is a protocol which is responsible for sending and receiving the files within your network. So let's say when the user is sending a request to download some file to the server, and the server is going to reply, and they are sending and receiving some files. Maybe you are downloading some files from server or a normal file transfer in both the directions. Maybe you're downloading some directories or some files, and that's what FTP protocol will take care of that. It allows you to send and receive the files from one machine to another machine. So for sending and receiving the files, there is a protocol called FTP which will look after the things. Now there is something called Telnet protocol. Telnet allows you to access the remote device. Like in the basic CCNA, we have seen that if you want to access a remote device, you don't need to go to the command line over there. We can just type CMD, and then I can type the IP address of the device, and I can access the device remotely by sitting here. So maybe that is in my LAN, or it can be in a different location as well. So Telnet is an inbuilt protocol inside your TCP/IP which will allow you to access a remote device, a remote machine, by sitting on my local machine. Now that's something what it will allow you to do. It works on port number 23, and it's a default application inside your TCP/IP. Now there is something called SMTP protocol, simple mail transfer protocol. Now this protocol is majorly responsible for sending and receiving the mails. Like I'm sitting here accessing some Gmail, some kind of things. The request will go to the SNMP, the Gmail server, and the Gmail server is replying back. So it's like your entire centralized storage is all the mailboxes, everything is stored in your mail server, and then this SMTP protocol will allow you to access those mails and send and receive some mails like that. Apart from that, there are some other protocols like IMAP, POP3. These are the other kind of protocols which can be used for general implementations, but in general we call it as SMTP protocol, which is a TCP/IP protocol again. Now apart from that, there are some other protocols like TFTP. TFTP protocol is used in, it's called as, it's a type version of TFTP. It's a modified version, and the major thing is it is used for sending and receiving only files, and especially this is used if you're doing some backup restore of any specific configurations, especially in the Cisco IWAs. If you're doing some backup of your IWAs or backup of your configurations by using a backend TFTP protocol, or in case of Microsoft, if you are doing some remote installation services, or in 2012 they call as Windows deployment services, where you can install the operating system from the LAN, just like booting from the LAN. The backend protocol which will allow you to do this job is TFTP. So trivial file transfer protocol, which is a UDP based. Again, UDP TCP will be seeing that more in detail in a separate section again in the later on topics. Now, there's another protocol called SMTP, SNMP. SNMP is Simple Network Management Protocol. Now, SNMP protocol is for specifically monitoring your network. So, monitoring network means, let's take an example. You have a very big network in your company network. You got plenty of routers and then switches, and then you got a big floor, and then you have all the switches connected here in the building, and then it's connecting to some router here, and then that router is connecting to some ISP like that, and it's going to be a very big network. Now let's take an example. There is a user connected here. That interface goes down. So let's say the user complains that he's not able to access internet, or he's not able to access the resources on the outside network or inside the LAN. Now there is some problem. Now there is a problem with the switch, mostly the port number or the specific port, or it can be something physical connectivity like that. Now normally we can have something called network management servers, where there is a specific computer which is installed with some monitoring software, which is going to give the logical topology of how the devices are connected, just like we can see them on a packet tracer, how they are connected, similar to that one. It can give some logical view of how the devices are connected, and in case if something goes wrong, it's going to send some alert message to the network server about that failure, and the administrator can see that message. Either it can send some alert messages on the server, or it can even generate some email messages. Now that's what these monitoring tools are generally specifically for used in the production networks. Now we call them as network monitoring tools, and the server where we install that particular software, we call it as network management software, network management server. And then the backend protocol which will provide all this information is your SNMP protocol. Now SNMP protocol will gather the information of each and every device, and it will provide the logical topology of how the devices are connected, so that in case if something goes down, then it will generate an alert message, so that the administrator will come to know about that particular failure immediately. Even it will provide you some information on the CPU resources of each and every device, and the network uses network utilization or a bandwidth utilization kind of things as well. So this is something really very useful tool in the production networks, but at the end this all process in the backend is done by a protocol called SNMP. So the next protocol, we have something called DNS. Now DNS stands for domain naming system or service. It's going to resolve the fully qualified domain name with an IP address. Like take an example, we are sitting here, we are going to type www.yahoo.com request, but in general the devices, they don't talk to each other based on the names like we are giving in the URL path. This is our URL path or the URL path, and then the request goes to the near ISP, and the ISP is going to maintain a DNS server, and this DNS server will have a mapping of the Yahoo server and what is the IP address of that particular Yahoo server, and based on that it will forward the request to the internet. On the internet it's going to find that particular IP address device, and then it's going to provide information back to the ISP saying that okay, you want this naming convention or the naming, okay, so Yahoo server, and then it's going to send the reply, and it's going to define what is the IP address of that server, and then the request goes to the internet and then come back to the specific Yahoo server, and then it will reply back. But exactly what DNS server is going to do is DNS server is going to maintain some database which has the name to IP address mapping, just like we have in our telephone directories. If you take your normal mobile or telephone, in that phone what we do is we generally add the number, and that particular number is mapped with a specific name. So whenever I want to speak to one of my friend, I don't need to remember the number, I don't need to memorize that. I can simply search the name, and I can simply give an option called dial, and once I give the dial option, automatically it's not exactly dialing to the name, it's actually dialing to the number, because my mobile directory is having the mapping of the name to IP address. So that's what the same job DNS is going to do. Domain naming servers, it allows you to use the domain name rather than to specify an IP address. It maintains the database of IP addresses and the host names. So again, this is one more protocol which will allow you to resolve the host name into IP addresses. Now there are some other protocols. Again, I'm going to discuss some of the major protocols here. Like we have something called DHCP protocols. Now DHCP stands for Dynamic Host Configuration Protocol. Now what exactly it is going to do is it's going to dynamically assign an IP addresses to all the hosts, we can say. Now why do we need this dynamic IP addresses? Let's take an example. In any organization, let's say you have some 200 devices connected in the LAN, and probably going to each and every device, assigning the IP addresses is not an easy job. So we're giving a manual IP addresses on each and every device is not an easy job. And also you need to manually assign the IP address, subnet mask, default gateway, and you have to tell who is the DNS server, and so that the PC can send a request, something not really scalable. So normally what we can do is we can have a centralized DHCP server. What I can do is I can configure something called centralized DHCP server, and in that server I'm going to define all the range of the IP addresses. I'm going to define what is the starting IP I should use, what is the ending IP I should use, and what is the default gateway address, so that if any user want to go to router or outside the network, what should be the default gateway. And then I'm going to say what is the DNS server, so that if any user want to resolve the host name to IP address, and all this information will be forwarded to the DHCP server, and the DHCP server's job is to resolve or to reply to the request. Like here, if I power on my computer, it's going to send a broadcast request to everyone. It's going to generate a broadcast request saying that is there anyone, this is my MAC address, and it's going to ask that is there anyone who can assign me an IP address. Now all the devices will ignore those messages because they are not authorized to do that, but the DHCP server is going to listen to those messages, and it's going to see the range of the IP addresses and these parameters, and it's going to reply back with the available IP address. Let's say there is an available IP of 1.5. It will assign the IP address of 192.168.1.5 to the client automatically. Now that's what we call as dynamically assigning the IP addresses or to the host. And not only that, we can also provide some gateway and DNS information also to the DHCP server. And if you have any changes to do in the future, we just go to the server and we can make changes easily. And also it is scalable for big size networks. So we prefer to have some dynamic IP addresses for all the hosts except router. We don't want dynamic IP on the router, because router should be a static IP. Except some servers, maybe switches, we don't want to change the IP addresses. Some special devices like firewalls, we use static IPs for them because we don't want to change the IPs in the next time when they reboot. So we prefer to have static IPs for all the special devices, but mostly for all the end users like in normal computers, we always want to have them automatic IP addresses assigned to them. So that's what job DHCP is going to do. Now to automatically work with the DHCP, we just need to give this option, obtain IP automatically, and then this option is by default selected, and obtain DNS server automatically. When I give this option, whenever you power on the PC, it's going to send a broadcast request in the LAN for requesting a IP address. If there is a DHCP server, you can get an IP address from the range, and we can verify that in the command line by using IP configuration commands.